Welcome back to your third video lesson. Actually, instead of calling this the third lesson, I'm actually going to call it 02.1, as we're just briefly going to go over the improved Hello World program we discussed in the last video. I just wanted to touch up a couple of things, and I think this will be no longer than 10 minutes, so I didn't really want to call it our third lesson. So anyway, I've went ahead and made a new project, 02.1, Improved Hello World, to differentiate it from our previous project. You notice it's got the standard template here. What we're just going to do for this one though, so we're just going to open up our old code from the last video, select it all, copy it. We're just going to copy it over into our new project. That way you can kind of have for reference everything we did in the last video saved off. So let's just compile and run real quick just to make sure we're where we left off in the last video. And it looks like we are. Increase the font size here, so hopefully it's a little bit easier to see on the screen. And also the comments I darkened because after I was watching my video, last video, you could hardly see the comments in it. So hopefully this highlights the letters that we're working on a little bit better, and you can see the numbering scheme, easy way to count out the string. Okay, so a couple things I want to do. Let's first one is I want to go over the functions a little bit more. If you remember the last one, we created this new function called getName, and it returns a string, and it takes no parameters. And basically functions, once again, how they're defined is just like a variable. You got to determine if it's going to take a string or not, like your first entry. Variables can also return no strings, so which it can be known as void. Void just empty, it's like not going to return any strings. Give it a name. Then there's parameters. We haven't really used the parameters yet. I might do that here in this quick video. We'll see, but you can insert take some parameters. Say we're doing some kind of math function. We could actually send it, say, you know, values I and j or a and b, whatever. Perform some kind of mathematical operation on it. In that case, we'd actually probably return a value too. I just want to give you kind of a quick overview of the function setup. And again, functions usually got braces. And another thing I did not cover in the last one, we can look at that now. I'm going to take this whole function. I'm actually going to move it to the bottom of the program. Not that it really matters, but as our programs get bigger, it's usually easier to have the main up top and, you know, bury all your more complicated code so it's off the screen in the bottom. The only problem when we do it this way, you know, compile and run quickly. The only thing I've done, remember, is just move the getName here. But as you can see, in function main error, getName was not declared in the scope. So we're going to error right away. Well, what's going on? The only thing I've done is move this code down here. Well, the problem is in C++, the compiler basically starts at the top and works through. So when it gets here, it has no idea that the getName function is in here yet because it hasn't went that far, so it spits out an error. So in order to get around that, what we can do is we can declare the function ahead of time. So instead of putting all our functions up on top and have the main buried, what we can do instead is just take the kind of initializer of the function or declaration of the function and put it up here. It's just kind of a repeat of the first line of the function. And that we will need addition of a semicolon up here. So while this is the actual function definition and function code down here, this is what's called the declaration of the function up here. You can kind of think of this as the same way as like a variable. I didn't really cover the variables too much in the last lesson either, but you can declare them here. So we're just actually declaring the variable name, but we're not really setting it to nothing here. It's just some memory set aside that's just got random values aside right now. Later on, like down here, is where the name actually gets some input from it. So it's kind of, we're declaring it, and this is actually where we're actually defining it or where it's being assigned something. So it's the same concept with functions here. Up here, we're just simply declaring it. We're saying, set aside some memory. At some point, you're gonna encounter a function called getName. It's gonna take no parameters, but it's gonna return a string. So the compiler just kind of sets that aside. So then when it gets to here, it's gonna know about that and say, okay, but later on, I'll figure out what's going on. So it's just kind of a heads up to the compiler. So now we go ahead, build and run the program. It runs exactly as before. And the same thing with the variables again. I would not need to actually declare that separately. I could actually just declare it at the exact spot that we're going to first use it. Sometimes it's cleaner up here, declaring all your variables. But depending on the situation, if it's just kind of a one-time use or a temporary variable, it's okay to declare it closer to where it's actually used. And here we can declare it string name equals getName. Can't leave it in two places because the compiler is going to complain if I do that because it's already been declared. If I get rid of the declaration up here, I can compile and run and see that the program runs exactly as before. We can do the same thing with message. Instead of declaring it here, we can actually just, actually in this case, I can just declare it right there. Yeah, kind of holds up my numbering scheme here, but we can fix that quickly. There. So I got rid of a couple extra lines of code that didn't really need to be there. It cleans it up a little bit. So again, it's going to run before. We're just declaring the string message right away and assigning it this initial value. And again, we're declaring the name, but assigning its value all in one line. So either way is valid. This way it probably makes a little bit less wordy, a little bit easier to read, but depending on the situation. Again, if it's maybe a variable that's used all over the place and maybe you assign an initial value, it's nice to keep them all on top, but it's okay to use them closer to where you first assign them as well. Okay, that was kind of just a little bit review, and we've really made no major changes yet. I think the next thing we could do with this, I wanted to also show that we could output this actually printing into its own function as well. So in addition to the getName, we could create another function. And this function would actually take return no values because we're just going to basically print it out. And we can just call it like print message or something for this example. Nothing too creative here in the naming. But in this case, instead of returning something like we did a getName, we're actually going to have to take some input. And we're going to actually feed it the message. And again, the names don't have to match, so we could do just something like, or just M even, We're going to take some variable. We do got to declare it though. That's going to actually be a string. Okay. So it's a function, print message. It's going to take a standard string variable as input. Again, we put the braces, put all our code in here. And for this, we're just going to grab, let's see what we got here. My name is. Okay, we'll just grab all this code this was just help add some lines between it. So we'll actually take all that. We'll take this as well, because this is all the output here. And we'll just, oops. Cut that out and just paste it all down here. And since we're using M, again, they could be the same, but I just want to emphasize that it's not the exact same variable because each function gets its own local variable. But again, if I kept it a message, this would be a different message, the one up in main. But again, for this tutorial, I just want to kind of emphasize that they are different. And once again, since we're actually putting the code or the function down here, we actually have to declare it up here. So cut off there. And end it with a semicolon with a declaration. And actually here you do not need to have the variable. You just have to say we're going to provide it some string input. Okay. And that looks good. So then here where we did have the output statement before, again, we can just call that function. So we'll be calling print message. And we're going to give this input basically our message variable, what you can see here. Semicolon. If I compile and run it, we should get the same output as before. So again, no real technical changes to it. I mean functional changes to it, but we have behind the scenes busted out our functions into an input section and an output section. This has kind of reduced the clutter into the main section to just kind of our message manipulation code, which we could, if we really wanted to, bust that out in the function too. But right now, this is more for demonstration than trying to optimize code. And one nice thing too in code blocks, like once you're done, get names pretty vetted. We're not going to probably touch it again. Print message, same thing. You can just click these little boxes here to shrink the code. Kind of just gets it out of your face a little bit. You can concentrate on main. So what we got here is our original Hello World. This is my first C++ program. We're calling our get name as we just went through. We're still working on we're erasing the capital T, and we're inserting some new text along with the name and correcting for the capital T that we missed. But one thing that you notice, this is just a modified version. It'd be nice to be able to show our original output here before I made the modifications. So one thing we could do for that is we could maybe make a little menu item. And this is, it's really not a big thing, but I just wanted to introduce the concept because in the next couple of videos, I'm actually going to introduce kind of a overarching project for this video series, what I have planned. What I want to do is actually build kind of a main wrapper program, so to speak, that will build a menu, and it's just kind of going to be like a launching pad for a bunch of other programs you write. So basically what I have in mind is by end of this video series, you're going to have a portfolio of different projects. Nothing too complicated, but we'll get some pretty heavy functionality in some of them. But I want this kind of overall wrapper project that you're going to launch, and it's going to display a menu, maybe 10, 12 items that you will be able to just easily select. Select one, it's going to launch your first demo program. Then you can leave that, go back to the main menu, select another one, and so on, and have an exit function. So I want to introduce a little bit of that functionality here and there, because once we get to that point, it's going to be kind of complicated. We're going to be using multiple files, headers, classes, so piece by piece will be a little bit easier. So I'm just going to add a kind of a small menu here just to kind of get our feet wet a little bit on it. So see here in main, underneath, we can just do, it don't really matter where we put it here. Probably right here would be good because the logic's going to break the code up here. We'll just add another standard cout statement. I'll put some a prompt for the user, and we'll do something like this. Nothing too formal here. Okay. And we'll just end it where this be a prompt, so we don't really need the end line here. So we're just going to output prompt for the user. Do you want to run version 1 or 2 of this program? Enter 1 or 2. Okay. And we're going to have to gather some input again. Let's do a placeholder here. Let's just create a little variable x. That's just going to hold whatever the user returns, 1 or 2, and we're just going to act on that information. And a couple ways to do it, but let's introduce the if statement here. So we've done a couple loops already. An if statement is kind of a logical operator. It's make some space here. So it's kind of if some condition is true, then like do some code, you know, XXX. So like say certain thing is true, we're going to print out the statement. If it's not true, it just skips over this. And if statements come in different ways. You can just have a standalone if statement, kind of like this example. You can expand on it. It could be the same thing, some code down here. And we can also, you can have actually multiple layers. You can also have an else if statement. So if this condition is true, else if this condition is true. And the final else is kind of like the ultimatum. If none of these other conditions are true, you know, run this code down here. But we'll discuss that a little bit more later on. Right now, we're just going to use the if statement. And for here, we're going to, once again, prompt the user. We prompt them here for the input. We actually need to create a variable accept the input. So we're going to use a standard cin to actually gather the input. And our extraction operator to get the input. We're going to want to accept x, assign console input, extract it, and assign it to variable x, which is expecting an integer. We're going to do 1 or 2. And let's actually add another condition. This is going to be more complicated than I want to do, but okay, these two ampersands are actually and condition. There's some logic conditions in C++ that we'll cover later on, but just shortly, ampersands is and, like if this is true and that is true. There's also, we can use pipes for or, if this is true or that is true. We looked at the other one before. There's just an exclamation mark, not, if this is not. We'll cover that later on. I just want to kind of briefly touch on that. I'm going to actually add this condition. So not only do we accept the input x, is cn equal to x, but and we want to check to see if x is equal to 2. And this brings up another topic here. You notice for me to check if it's equal to 2, I actually had to use 2 equals. Well, if you noticed before, every time we assigned a variable to something, just like up to here, a message equals something, or if we did work with variables, we could make a variable integer and we can equal that I equals, you know, some number. An equal sign by itself is just assigning, saying I equals to 9, or assign 9 to I, assign the value of 9 to I. So equal by itself is just more of an assignment operator. But when we want to actually check to see if something is equal, you know, is x equal to 2 in C++ and many other programs, 2 equal signs together checks for that condition. So I just wanted to point out that distinction. This is equal to, and this is more of an assignment. Name equals get name, or get name assigns into name. Okay, so we're gonna take our cin, take x, and in addition to the input, since it's inside an if statement, it's kind of a logical check. So if we got input and x is equal to 2, let's do something. So in this case, this if statement is going to look like a logical check, depending on what the user entered. In this case, enter 1 or 2. And they could actually enter all kinds of stuff. And the reason I'm doing it this way is how it's going to work is the user's going to get a choice. They can either type in 1 or 2. And so it's going to work. Program's going to work one way. I think the first one, I'm just going to print out the original. Then we pick version 2. Excuse me. It's going to print out our modified code that we manipulated. But they could enter 1, 2, X, Y, Z, 1004 and stuff. So we just really want to check that they actually enter the integer that's equal to 2. And if it's not equal to 2, our default is just going to be 1. So if they enter anything other than 2, we're just going to run the first version of the program. That's kind of where we're going here. It's a bit more complicated. I'd like to go over the third tutorial in the series, but I think this will work out okay. And again, if statements, just like loops, you need braces. I should clarify that a little bit. Hate to confuse you too much now. They do need braces, but if there's just one simple statement afterwards, say you're just going to see out is true. Some simple statement, it could actually follow as long as it's just one line and it's immediately after the if statement. You could get away without bracers, but for the most part, using the braces is pretty much common practice. And plus it helps kind of identify your code because you know just at a glance that all the code within here applies to this if statement. Okay, so we checked out, we're taking the input, assigning it to X, then we're doing a check right away to see if that X is equal to 2. If it is, we're going to run the code inside here. So that code inside here is going to be the improved version of our program. So what we're going to do is all this manipulation stuff. We're going to cut from down here. We're actually going to include it inside this if statement. Format that a little bit. And usually when we assign stuff, whether it's in loops, if statements, or whatever, there's usually an indentation in here. To the compiler, it makes no difference. Some programs like Python, the indentation does matter, but since we're using bracers to kind of signify where the code is, you know, this could be actually anywhere. It could actually all be lumped up in one line too, as long as you respect the semicolons. But it's for readability for us programmers. It's nice, a little indentation. That way you can just see at a glance, oh, there's this if statement. So everything in these braces and that's indented, you know, must be included in there. Again, these simple programs, it's hard to see, but once you start getting hundreds of lines of code, it is kind of helpful. Okay, so the changes I just put in, again, the overall functionality of the program is about the same. But what we did is just added the if statement, and we're just prompting the user, hey, do you want to run version 1 or 2 of this program? If they pick 2, it's going to run our new and improved one, where we're going to actually query for the name, do some manipulation, insert that name. If they pick 1 or basically any other choice, we're just going to run this original string that we created. And let's see, go over that quick. I think that is all we need. Let's check, cross your fingers. Okay, looking good so far. Do you want to run version 1 or 2 of this program? So I'm just going to click 1. And there you go. Hello world. The new line, so it starts a new line. This is my first C++ program. What do we see here? And let's run it again. Since we don't really need a compile, we can just use the run key. This time, let's see what happens if we hit 2. Enter your name. So we know it's working. Because as you notice over here, we're only going to call the getName function, which is the prompt to get our name, if the statement is true. So we know we selected 2, we assigned it to X, it checked X equal to 2. Yes, it is. Well then, execute this code. First line of this code is run the getName function, which as we saw before, prompts us to get the name, enter. Then once it gets the name back, we're going to erase capital T up here. We're going to insert some text, my name is, plus the name we just got, and a small t, and create hello world, my name is Scott. This is my first C++ program. So we got just kind of a real basic menu here. Well, it'd be a much more comprehensive menu in the project that I'm talking about. But it does show you, A, introduces you to the if statement, and B, gives you a real simple way if the user can input one choice or another. In this case, we can see just a simple version of it. It's your improved version. Caps lock is always fun. And also, you know, I'm going to hit T up here. That's where that logic in the if statement comes from. Basically, no matter what I hit, you know, I can put in some big number. It's just going to run the first version. So the only time that the if statement is going to execute is if we put in the integer 2. So if we put in letters, huge numbers, anything else, it's just going to default to 1. Okay, so I think that pretty much wraps it up for this program. And we'll also be done with the improved Hello World at this point. That's why I just want to kind of make it a sub or kind of a stub off the Hello World, improved Hello World lesson rather than going into lesson 3 right away. So that's it for now, and see you in the next video.